Hi everyone, very good afternoon. Thanks for joining in for today's session on code testing and optimization. So today we have with us Mr. Sanjay, who is a technical architect at BFSI Europe Central in Tata Consultancy Services. So we extend a very warm welcome and a sincere gratitude for you to be a part of this session. Also for delivering valuable insights and exposure to the grand finale participants of Smart India Hackathon 2024. Over to you, sir.
Yeah, thanks, Abhishek. Are you able to hear me?
Yes, sir, you're audible.
Okay, yeah. So I'll start off. Um, uh, 1 second. I think I need to share my screen. Is my screen visible?
Yes, sir, we can see the deck, sir. Yeah.
Okay, yeah. Okay. Yeah. So I guess the parts are working in various areas, but the field I've chosen is the applicable for software development and testing. But yeah, similar approach they would have to take for other areas where they would be working. Yes, many of these things would be applicable, but again, to their field, they would have to apply and see what things are applicable or what things are not applicable and what is new which need to be put in. So that's what they would have to look at. But the field I have taken is software application development and testing for an end-to-end web application. Yeah, so this is what the agenda looks like. I'm going to cover what is code testing, the types of testing, code optimization, the techniques for code optimization, then best practices and tools for testing and optimization. Yeah, this figure basically tells the various aspects that are involved in software testing. The central part where we have this laptop being shown with the bug. It's the basically the software which is being tested, and then we are testing this application, and then trying to this is the system under test, and then we are trying to find out all the defects. It could be various kinds, which we will see. Uh, so that is the main goal. And then for this one, we would be having the code which has been developed, which needs to be tested for. Uh, and then there are various tools we use for testing this one. And then uh, as we go along, uh, then we have this the final picture, which is the uh, performance test and optimization. So we first of all test whether it meets the requirements, and then we also check once it meets the requirements, it should also perform the required uh, optimized way. So using the various tools, we will be doing that. Uh, yeah, and yeah, I'll go through this session and then we can take up the questions towards the end. Uh, so we can look, participants can keep typing their questions. Then we'll go through those questions and then answer.
Awesome.
Yeah, so that's okay, right, Abhishek?
Sure, sir. We can go ahead with that, sir. Yeah.
Okay, yeah. What is code testing? Basically, this is the process of evaluating the software which has been developed so that it meets the requirements of the customers, whatever this software has been developed for, and what requirements were given to the development team. So the software would be evaluated for all those parameters, for all the requirements. Uh, and then the end goal is to find all the deviations, fix all those defects, and then ensure that it meets the requirements well. And it's not that on day one we will have the perfect software. Most of the softwares evolve over time because it is unless it is mission critical, it is really difficult to uh, test for 100% and then go live. It would be too time consuming, and we will not be going in with the product launch if we keep waiting for the 100% uh, coverage of the code. Uh, so, yeah, then we basically, why do we test is to ensure that code meets the requirements, then improve the reliability of the software, reduce defects, then code is maintainable as well. So there are two types of requirements. The non-functional requirements, and then the one which has nothing to do with the how uh, the perspective of what the application is supposed to do. Uh, so the non-functional requirements, it's like whether the software is in usable format, whether it has all the security that is required, whether it is internet facing. If that is the case, whether it is secure, can anyone hack into this system? Um, is it under demilitarized zone so that no one can hack in and extract data or manipulate data? So those are all the non-functional requirements, which does not directly get the requirements from the end user perspective. And then we have the functional requirements, which basically uh, goes through the functions of the application, which have been given by the basically the stakeholders who would look at what the end customers would need, and they would come up with the functional requirements. So these are some of the differences I have highlighted for the functional and non-functional requirement. So the functional basically says what should the system do. Uh, 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 these are all the functions of the application. But in the case of non-functional, it just says how it should do, uh, and then whether it is secure, whether um, it's able to perform at the required response time. So those are all the things which we look at. And then uh, the behavior and features of the system, uh, and then the performance, usability of the application is what is the non-functional. And then scope is the various actions when the end user uses this system, what are the various actions and the operations the end user can perform. But in non-functional, it is the various conditions under which it should execute, and then the business requirements, and then it's easier to measure the functional requirements because we know what is the input specified by the end user and what is expected when that happens, because that has been clearly defined as the functional requirements on what the application should perform. But in the case of non-functional, there are various things which cannot be defined and which improves over time. And then the testing is based on the functional testing. But in the case of uh, this non-functional, it is the performance, the usability testing. So there are various other things which needs to be done. So these are all the various non-functional requirements. There are many more. I have taken the few important ones. So the usability is how usable is the application. We would have seen many web pages which are too cluttered, too much of ads, too much of flashing things going around. And uh, when we see those kind of applications, we tend to go away. It's not user friendly. You would have to search through the whole page to find the right information what you are looking for. So that is one aspect where we need to look at uh, how usable is the application, how easy we can make the application usable. uh, the security aspect, how secure is the application, whether it is intranet based, whether it is internet facing. If it is intranet based, yeah, the security requirements might not be too stringent. When it is internet facing, there are stringent security requirements. So in that case, we would have to do much more thorough testing, also get it certified from a external agency that we do not have any security loopholes, and it becomes more important when there is financials involved in this whole uh, application. Then how maintainable, how reliable. So uh, this time when we use the application, it works. Next time when we come back, if it does not do well, say for example, you say, I want to transfer 100 rupees. Yeah, this time it works. Next time it transfers 1,000 rupees. So the system is not reliable. So we need to ensure the reliability uh, uh, of the application. Uh, then portability, if it needs to be put across different environments, scalable. How scalable? Say, for example, we have festival during festival sale going on during Diwali. In that time, I'm expecting 10 times the load of what is in the normal time. So will I be able to scale to that loads. Um, Performance, whether its response times are same across various during the peak loads. So these are all various things which we look as part of the non-functional requirements. Yeah, so now going to the functional part from here on. Um, uh, so it's clear, right? Fine. It's audible, right? Abhishek?
Yes, sir, you're audible. Yeah,
Yeah. So the speed is okay. What I'm going at, right?
absolutely, sir.
Yeah.
Yeah.
Okay. Yeah. Yeah. Okay. So uh, uh, these are the various uh, types of code testing which are there, and it's not limited to this one. Different organizations followed different ones. Then there are a few more like the white box testing, black have taken these, uh, which are the important ones. So the first one is the unit testing. As we do the development, it is the responsibility of the individual developers to test uh, the components which the individual developer is developing and ensure whatever the requirement they were supposed to implement uh, cover this component covers that one and completes the requirement correctly. Um, this way, once we uh, ensure the correctness of each small piece of code, then once we integrate with the others, it becomes easier to uh, ensure the complete application works. And then we have the integration testing. When we are developing an application, it's not that application is completely working on its own. Majority of the applications interact with various other applications to get the whole thing completed. Say, for example, Amazon. Uh, uh, we buy the product, then payment we need to do. So payment, Amazon cannot have the payment system also with the payments going into the bank. So we need to integrate with an external agency which maintains the payment system. So they would have different integrating systems, and the two larger organizations could have various integration points. So we need to ensure each and every one of them works perfectly. And then the functional testing, ensuring the requirements are met. Then the performance testing to ensure that um, the application is responsive as per the expected by uh, by the users. So no one would like to wait for a few seconds or minutes. Everyone wants the response to come back in next a couple of seconds or max 5 seconds. They would be waiting. We need to ensure our application is responsive and also able to scale for the uh, peak periods. And then the regression testing. to ensure as and when we uh, keep doing uh, various methods of development. Um, uh, so we need to ensure that the application, as and when we build new functionality, the old functionality continues to work and it does not break. So that's where we ensure this regression testing. And then the user acceptance testing to ensure that the application meets the requirements, and then the end users test this application to ensure that it meets the requirements, and then they do the sign off before the project product is launched, or upgrades are launched for the product. So this is how a unit test. These are all the various steps we would do for doing the unit test. Basically, um, the developer does the development of the code, and then uh, uh, we choose the testing framework to uh, write the test cases. Uh, so we need to identify what are the different uh, components, what are the various test cases that have to be run for this component which has been developed. Then we need to set up the test environment. Um, it could be your development environment, or you could have a separate test environment, and then um, run the tests, analyze, and then refactor, and then if there are defects, you fix them, rerun these steps. Uh, so some of these steps are probably not required. In that, it will be basically running the test. So in this case, you would need to automate so that uh, rerunning all the test cases becomes easier, because otherwise running it manually, all the test cases, as and when we fix some small thing, we cannot run everything manually. So we need to automate at that point. So this is for the regression testing, how it happens. Uh, so uh, in this case, we plan for what are the various uh, test cases have to be run as and when the application is being developed. So generally, the all the basic requirements for an application would be tested uh, on each release to the production. In this case, we will not be doing a complete functional test. Uh, Majority, main important test cases are the ones of the functionality will be tested and ensure that um, all have been passed. Um, so this one, uh, a product is not launched once and then forgotten. We keep improving the product, we keep adding new features into the product, and then this keeps happening over time. So this sprint could be any duration. So this cycle, the initial cycle could be uh, a lengthy one, say 3 months. After that, it could be much shorter, depending on the project. This could be, say, 2 weeks or 4 weeks sprint. So as and when new features are being added, uh, we will be testing the features as part of somewhere over a year. whether the new features, whatever have been added, has been tested. And then before the release into the production, we rerun the regression test pack to ensure the old functionality is not broken. And these are all done by not the developers. We would have a separate set of team doing these test runs. Uh, and then, so as I said, uh, we would be having different integrating components within the application, and application does not work on its own. So uh, uh, because each of these components, uh, even before this one, each of within an application, there will be multiple developers who would be developing it. Uh, so we would integrate all of those, deploy it into a single environment, and then uh, uh, some of these components where we are going out into an external system. Many times we would be mocking those external systems and then test the application. And then once we go into an integrating environment, that is where we will be actually integrating with the external system, because these external systems might not be available in all the environments. They might be available only in the end user acceptance environment, which could be the user acceptance environment. So in lower environments, we'll have to mock it and test. In user acceptance environment, we will be actually integrating with this external systems, and then ensuring that it integrates well, and then we test for that one. Once it has been ensured that it is working, that is when we will be uh, working with the end user. Uh, Actually, I'm not sharing any uh, computer videos or animation. So the talk is done only by me. So I don't have any audio on the computer. Yeah. So we integrate and then ask the end user to do the end user testing on this one. So this is the performance testing process. In this one, uh, basically we identify the uh, performance scenarios. For this, we would be doing the uh, profiling of the application, and then identify the various scenarios which we need to test for. And then we design the test scripts, and then we set up the environment for this performance test. Um, and then we need to uh, put in the required amounts of load into the application, uh, so that the application in the lower environment behaves similar to what loads are expected in the production environment. So as I was saying, say during non-peak days, where a normal load is expected, uh, we should not be testing for that one. On a peak day, say when during Diwali, where 10 times of load is expected, we should be testing for that one to check whether the application is able to withstand that load, and also be able to scale up and down for the new loads which keeps coming. It's not that all the loads come exactly at the same time and throughout the load is same. So uh, when there are not much loads, we bring down some of the uh, uh, pods so that the usage is lesser, the charge is lesser on the application. So and then this needs to be tested on the lower environment to ensure it behaves exactly like the production. So we execute the script, we get the results, analyze the result, and then we again identify the uh, bottlenecks. Then if there are any fixes that are required in the application, we fix those applications and rerun this uh, test again. So this process continues until we have reached a fair bit of required performance. This is the functional testing process. In this one, we basically we have several sessions with the stakeholders who then this same thing is used for the developers and then the team which does the testing. So this functional testing team is a different team who basically understanding the requirement. They prepare the test plan. They write the test cases. They create the input data uh, for this one and then do any setup that is required, which could be the master data for this application. Create the input data and then they execute the test cases and then they compare the uh, actual and they would have come up with the expected results because they understand the requirement. So they have the expected outcome of how the application should behave and what should be the results, all the various validations the application should pass through, all the boundary cases, all the scenarios under which the application, all the failure scenarios under which the application should behave well and not shut down. So proper messages should be given to the end user. And if there are any deviations, if it does not work as per the requirements, they will be logging the defects on this one. At the end, before going into the production, basically this is when the end user who would be using the application would be coming in. Say in the case of Amazon and others, yeah, the end user cannot really come in, but within the organization, they would have few teams which would have people who would behave like the end user, who would be doing all the uh, testing as an end user and ensuring it works correctly. So they are the ones who would be doing the uh, uh, verification and then sign off. and then only the application would go into production. So the application going into production also, uh, and depending on the type of organization, there are various steps that are involved before it can actually uh, go into production. These are the code testing process where we write the test cases, then define the expected outcome for each unit of code or each component or each screen, each functionality. Then we run the tests on that one. Uh, uh, then check the behavior. If there are defects, those are logged into a tracking system, and then uh, uh, based on that, yeah, it goes into the development team again. They do the analysis and then decide whether it is the code defect or whether it is not a defect, whether there is a defect in the requirement specification itself, whether there is a problem with the data setup. So there are various things that could go wrong with the uh, defect itself. It could be various layers it could be coming from. They identify, and then accordingly that respective action needs to be taken. And then we need to automate this whole process so that repetitively this can be executed instead of doing manually. And then uh, uh, this process needs to be continuously done. So this I have mentioned for the unit testing, but this process remains same for all the other life cycles also. Only thing is the steps are different. As I mentioned, yeah, so different teams would be involved. But the process remains similar. So then next is the optimization bit. Uh, in this one, uh, basically, we need to ensure that the code is able to meet the uh, required speed. The application does not crash when additional users come. Um, so it's able to uh, respond back within the required time. The end goal of this optimization is to improve the performance of the application and ensure that the application works as per the requirement. Uh, just because we want to achieve performance, we should not ignore the functionality. So, and then uh, we also need to see when do we need to do the optimization. Uh, there are various aspects there are functionality which might not be used too frequently. It might be used once in a month, once in uh, uh, only during the onboarding process. So it might not be invoked too much. So we might not have to spend too much time optimizing those. Uh, so then when is the performance critical in the case of large scale systems, real time applications? So depending on the type of application, we need to see Uh, and then for this one, we basically need to identify the bottlenecks and then try doing the optimization of the uh, Ola application. Uh, so we can take quick questions and then I can continue with the next slides. If people have any questions, we could take up a few.
Sure, sir. Sir, I guess we don't have the domain specific related queries as of now. So for the time being, we can proceed ahead with the session, sir.
Okay, yeah, then
Sure.
okay, yeah. So the technique, this whatever I have come up with is all based on my experience uh, resolving this, doing this code optimization across multiple applications during my experience. So majority of these are from my experience, where we have improved the performance of applications. Yeah. So the various aspects that are there are the algorithm which we choose for the uh, code. There are various algorithms which anyhow I think the students over here are more familiar because they would have gone through a lot of these algorithm. So we need to select the best algorithm which can perform the best at large data sets. Um, and then next one is the data structure. This also I'm sure they would be quite familiar with about the various ones when to use the arrays, linked list, hash maps. So uh, in uh, all these algorithms and data structures really help improving the performance. So the right choice needs to be done during the development. At the initial stages, or in case later on when we are improving performance, um, so we can look at these pointers to see if there are any, because if we are, say, modifying or improving performance of someone else's application, in that case, yeah, we can look at all these aspects. And then the network ops, uh, say, for example, because we have various integrating systems. So we need to see, say, some component might be extremely slow. So in that case, we need to see, are we really doing too many network ops to fetch the data or the update the data, whatever. So we need to relook at that one in case we are doing. So we need to see, are there ways to redesign that one? Are there ways to fetch it and store it somewhere? Um, is there a way to cache that data? So we need to look at that one because these networks ops are definitely going to add to the delay. Uh, uh, and then the next one is the loop uh, optimization. So um, this becomes too important is, uh, yeah, yeah, if say we are looping through 10,000 records, if we look at for one user, it is 10,000 times it went through that data. But if say, as I was saying, for a Diwali sale, 1 million customers would be coming. So if you multiply 1 million by, if it is looping through for 10,000, then it becomes very inefficient. So these are the things which we need to look at, repeating the loops, whether it is required to loop through, whether while getting the data from the database, is there a way to narrow down the data? Whether there are expensive operations in the loop, whether we are doing any network operations, whether we are doing string concatenation, for example, in Java. Uh, Too many string concatenation also puts a delay. So we need to really look at, because uh, we need to see what will be our peak load and look at all these aspects. Uh, then the memory optimization. Uh, we need to see how do we minimize the memory usage for each section of code, because uh, sometimes the applications could be big. In that case, because the application is used by uh, various components, memory is not only for your component. It is used by various components within the uh, application. Um, so you need to look at how do we uh, reduce the memory footprint for each component. Uh, and then we should consider streaming the data. Uh, uh, we cannot be, say, getting, say, 20, 30 MB of data into the memory and then perform. So, say, even if it is 20 MB, if we say multiply by 1 million uh, users operating at any point of time concurrently, then it will be huge. We'll not be able to run our application if we if we do that way. So we need to and then take decision. How do we reduce this memory footprint? How we can redesign the application? And then next is on the concurrency and parallelism. We need to ensure um, we are able to run parallel, because a lot of these technologies um, allow executing um, on multiple cores. So we need to see if we can utilize that thing and run on multiple uh, CPUs. Um, so the uh, a lot of these database operations also can be executed across multiple CPUs, and then Hadoop kind of system allows processing in a distributed manner. Um, so, for example, if we take the social media sites, they generally store 3 copies of this one in case of disaster recovery, uh, uh, s- uh, and they do not uh, uh, keep the data in all three of them at the uh, sync at the same time. That will be delayed process, even in case they lose the main server. at least they can fall back to the other one with some delay, which they would have had as the acceptable delay. So these they can at least fall back so they don't lose the data. Uh, yeah, so can look at that one. Then there are some heavy reports. Say someone wants to look at last 1 years of data from your application. So we should not allow that into the main application. Probably we can move that out into a separate processing, and then it can also work on. We can probably archive older data older than 3 months into a separate system, so that the live system is fast. And then we could run reports out of that other system, and then send out offline report to the end user, intimate them when the reports are ready. Uh, so yeah, we could do that. Then we can do lazy loading of the data. Then we could, for the UI application, do pagination. Then caching is one very important aspect in all these applications, because many times uh, uh, same data is requested again and again. If we keep going into the database to retrieve this data, the load on the database would increase dramatically. And then there is a limit on how much the database can serve as well. So in that case, we uh, move a lot of the master data uh, which are used into the um, caching system. Uh, but when we move the dynamic data, then you should be careful, because when dynamic data is updated in the database, you need to ensure the cache also gets updated. Um, so that you need to be careful of. Uh, so then uh, there is the optimization of SQL queries. You need to use index columns, then avoiding the select star. Instead, you should try selecting only the columns which are required. Uh, Avoid the glob and blob columns as part of the selects, because they do take huge amounts of memory. Then minimizing the number of tables in the join. Um, then using pre-compiled SQL statements parameters to execute efficiently. Then avoiding multiple nested queries. And then uh, uh, the next one is the debatable topic. Different set of people have a different opinion about this one. The um, Basically, what I'm saying here is trying to move a lot of this computational tasks from the database layer to the application layer. Um, and this one ensures that the database layer is lean. Uh, and then we are able to scale the application. So the application layer can be scaled easily. Uh, then one more aspect is the splitting up the whole monolithic application into multiple services, so that each functional component runs as a separate service. Basically, the microservices architecture. Uh, so that each component can be scaled separately, and only the heavily used components are scaled, and we don't need to scale all the components. So that way, uh, we do not need too much of infrastructure for all of the components. Uh, then the next one is the client side optimization, which is on the screen. We might not need everything to be loaded as soon as the screen comes up. There are some things which needs to be seen immediately, and then in the background, we could be loading the data and uh, so that the user does not feel the uh, application, the page is unresponsive. And then we could be using the CDN to cache all the static data at the nearest web server. So the first time load would take a bit of time. From next time onwards, when the browser cache is enabled, uh, it's able to uh, uh, render the contents much quickly, and then reduce and compressing the images to reduce the size of the image, minifying the CSS and JavaScript, um, enabling compressed delivery of data. So all of these can be looked at for optimizing the code. Uh, Next one is some of the uh, pitfalls for the optimization. Uh, so um, at the start of the project, as the functional requirements are being captured and being worked upon, we need to agree upon the non-functional requirements also, and then we need to start working how we are going to achieve those non-functional requirements, because if we are going to during some festival and we expect huge data, then we need to cannot be running it on a uh, uh, standalone server. Then we might need to go into a cloud uh, uh, where or we cannot be buying hundreds of servers and run it on those. The cost effective could be going into a cloud. So all these needs to be planned from the starting, because it would involve getting the right amount of budget, getting all the approvals, procuring the infrastructure or the hardware. So non-functional also needs to start off at the initial stages itself, and then we need to work upon that one, and then uh, not having the production like infrastructure for the uh, testing of our application in the lower environment. We need to simulate production like load, and then do the profiling of the application. So not considering the big picture, uh, instead concentrating on one small component. So we might improve performance there, but the performance bottleneck could be elsewhere. So we need to basically identify the uh, bottleneck by performing the uh, uh, also identifying which are the functionality that will be heavily used by the users, and then uh, put the right amount of load in those components, and then uh, identify the bottlenecks where the application is going to fail. Uh, so that way we don't waste time on on the functionality which does not need to be too critical and uh, uh, where we would not be spending too much time. So that way, we need to first profile it. Uh, so you use various profilers, analyzers, and then identify the bottleneck, and then start the optimization. And then uh, uh, we don't we shouldn't get into over optimization. We shouldn't uh, uh, focus too much on the performance at the cost of making it an unreadable or unmaintainable code. So we need to be conscious about that one. Uh, do not use complex algorithms. That makes it again complex to read and maintain. And then we need to manage the resources. We need to close connections, and then we need to use connection pools because we have limited connections to various systems. It could be the database or any other streaming systems. So we need to maintain the connection pool so that those do not we don't run unlimited connections and then one day we fall over on the application. So we need to maintain the pool and then return back connections to the pool, and then uh, ignoring scalability, say for the sale period. um, so how the application is going to scale up and scale down. So as we scale up, scaling down also is important because that would ensure that we do not get billed for unutilized resources. So those aspects need to be taken care. Um, and then uh, this whole uh, performance test cannot be done in on the day one of the release of the application. So we do build, deploy it, and then parallelly we keep doing this improving uh, uh, the application, looking at the various aspects. Many performance bottlenecks do show up much later in the even after say running for 4 5 years. Then a lot of performance issues could prop up. So this one should be a continuous cycle which we keep doing. So, archiving of old data is one more important thing which we need to do. So, and then, as I said, we shouldn't be attempting big bang optimization. First of all, it is too time consuming, and if we keep optimizing every bit of it, it will not go live. So we need to see at some point of time we are okay to go live, and then we'll continue with our optimization, and then we can keep doing incremental optimization, solving few problems, uh, and then solving some problems uh, could automatically resolve few other problems. So we might not have to look at that one. So first thing would be to uh, 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 the first objective would be to identify the major bottleneck ones, try resolve that one, and then see what comes up next and then resolve. So this cycle could keep continuing. These are all the best practices for the code testing and optimization. Um, uh, so I think I have spoken about uh, most of these, so I will not be going through these ones. These are all some of the tools that are used for the code testing at various phases. Um, uh, so there are these profiling tools for the gprof for C, C++. Then we have the Visual VM uh, to analyze the heap dump when memory uh, becomes too huge. Um, and then we want to analyze what uh, components are using up uh, the memory. Uh, so we could look at VM. Then we have the static and dynamic code analysis during the development time. So we have this Sonar Cube uh, to look at the code quality, the code complexity, the duplication, the security vulnerabilities. Then we have this JFrog, which highlights the security vulnerabilities in all the dependent jars which we use within our application. Then the Vera code. Uh, uh, this performs both the dynamic automated penetration testing and then the static code analysis. So this service is provided by an external agency. This becomes important if we are going on the uh, internet. Internet-facing applications definitely need to see uh, if all of these if our application passes through this Vera code security vulnerabilities. Um, and then for the database query optimization, we have the MySQL workbench, uh, uh, explain plans and query profiler. And then we use the AWR reports to go and look at the top 10 uh, the resource intensive SQL statements. And then we can see uh, which ones are taking the maximum time, and then we can analyze, tune those. So those should be the first we tackle. And then we have the ADDM report uh, to look at the root cause of the performance issue. Um, uh, so this is one of the application which I have optimized. Uh, Before our optimization, these were the figures. Not that as soon as we developed the application, these were the numbers. This application had been running for around 4 or 5 years. And then after 4 or 5 years, uh, this is when we started noticing the degradation in the application. And these are the different APIs the application had, and then these were the usage of these application for various APIs, and then the average response times, and the maximum response and the minimum response time. So we uh, basically started analyzing various of these. Uh, and then so basically, there are a few things like the ones which are heavily used are the ones which we need to tackle. So, uh, uh, if we see this one, the tokens, it has maximum number, it has a large number of hits, but again, the response time has been pretty good as well. So we don't really need to look at that one. So then we have this one, properties. And then the average response time is also 1 second. And then it's not too bad. Um, and then there are a few others, uh, uh, which say next one is this one with an average response time of 7 second. Yeah, so this is where we start looking at this one also. 3 seconds for 200 K. It's so we start looking at these ones, and then um, start seeing what are the issues, uh, and uh, whatever I talked about earlier. So those are all the aspects which we looked at, and then uh, so over multiple iterations, in fact, over a period of 4 to 5 months uh, uh, of iteration. Uh, over multiple releases. This is where we were able to reach many of these from here, which were 15 seconds, 7 seconds, 3 seconds. We were able to reach uh, less than a second to for almost all of them. Um, so the maximum response is for some requests only, uh, but the average is less than a second for all of these. Um, and then minimum also reduce. So that way, for multiple iterations, we were able to achieve good uh, response time, and then we were able to scale the we are able to scale the application over last 2.5 years. The application has doubled in the size. Still, it is able to maintain this same response time after all the uh, performance improvements which I highlighted earlier were done. Uh, so this is the summary which I put, which I just spoke about. So memory usage also came down, uh, and then we are able to perform well. So yeah, uh, this is all what I had to talk about on this one. So now we can take questions on this one. Any questions? I can't see the chat window. Abhishek, any questions in the chat?
I think we don't have the domain specific queries,
Okay,
so probably we can conclude the session.
okay. Yep, yep. Hope yeah, the session was useful for everyone. Uh,
So we would like to extend our sincere gratitude and thanks for you to be a part of this session. Also, you have enlightened the SIH Grand Finale participants with valuable insights and domain specific knowledge. from your vast experience. Thanks a lot for being a part. Also, there's an announcement for all the grand finale participants that we have scheduled a lineup for further sessions in this week. Request you everyone to kindly join these sessions because they'll enhance your knowledge. Thanks a lot. We hereby conclude the session. Thank you all. You may leave the meeting.
Yep. Okay. Yep. Thanks. Yep.
Thank you, sir.
Yep. Thanks. Yeah. Bye.
Abhishek, it is finished here?
Yes, sir. The session is concluded, sir. आप end कर दीजिए.
Okay, sir. Okay.
Sure, sir. Thank you.